Okay. Let's go ahead and take roll. Isaac. Zamian. Eileen. Nevia. Alyssa. Alyssa? Okay. Mia. Isabella. Antonio. All right. So, before we get into lecture, remember that on Friday I signed a review, and that review should be something that will help you study for Mr. Brzezinski's test this week. That review is for a grade. Take your time on it. You have plenty of time to do it. It's 15 questions, I believe. Okay, so it's not all that big. And it is due Wednesday at midnight. So make sure that before Wednesday at midnight, you email me the answered version back. Okay. Now, before... Okay. Okay, so what I was going to say is, last time we were talking about properties of radicals. We said that radicals are these things like roots, square roots, cube roots, fourth roots, all sorts of types of roots out there. And so they fall under the umbrella term radical. So if we had something like, I don't know, 81, square root of 81, that one's pretty easy because we know what the square root of 81 is. What is it? 9. Okay. Now I also said, what else can be an answer for this? But we just don't typically think about it. Not just 9, but what kind of 9? Negative 9, yeah. So remember that negative 9 is also an answer. It's just for now, we're not really going to think about it all that much. Later on, when we get into quadratics, this is going to become very important for us to remember. Okay. Then we said that we can have other types of radicals that do not come out to an integer for an answer. They have an irrational value. Remember that irrational numbers are numbers that we can't really write easily. They're things that have decimals that go on and on and on and on and on forever and ever and ever. And so if I have something like square root of 50, I can plug it into a calculator and try to get a decimal answer for it, but that's about all I can do with that. If I want to continue to do some math with this, though, a good idea would be to simplify it. So what we do to simplify is break it up into its factors, its prime factors. So 50 is 5 and 10. 10 is 5 and 2. Okay? So from this point, what do we need to be looking for? Pairs. Yeah. So the 2 and the crook here tells us that we're looking for pairs of numbers, 2 numbers that match. If this had been a 3 up here instead, we'd be looking for 3 numbers that match. A 4 instead would be 4 numbers that match. But again, because this is a 2, we just need a pair, 2 numbers that match. So we've got a pair of 5s there. And what does that mean we can do since we have that pair? Do what? I didn't quite hear you.
Oh, no, it's okay. Sorry. It goes on to the... You can pull it out of the...
Yeah, we can pull this out of our root. After all, this is like a square. This is 5 times 5, so 5 squared. And this is a square root. So square and a square root cancel and just leaves us with 5. All right, but what about this 2 here? What happens to it? Yeah, it gets left underneath that root. And so we can say that the simplified form of square root of 50 is 5 square roots of 2. And this is useful because this will probably allow us to do a lot more calculation with something like this than we would be able to do with just square root of 50. Any questions? Okay, we also said that we could multiply these things. So for instance, if I have square root of 24 and multiply that by square root of 8. So one thing that I could do is I could multiply in my calculator 8 times 24, since they're both square roots. Oops, that's 25. And I'd get 192, and then I'd have to break that up to get a simplified form. Well, I don't want to break up a big number. I might as well just break up these small numbers that I have here. So even though you can multiply square root of 24 and square root of 8 and get square root of 192, I think the better way to go for this is to break these up just as they are and look for matches. So 24 we can say is 2 and 12. 12 is 3 and 4. 4 is 2 and 2. 8 is 2 and 4. 4 is 2 and 2. And again, remember that if there's nothing written in those crooks, it's a square root, so I'll go ahead and put that in there just for a visual aid. So we're looking for pairs of numbers. So I've got a pair of 2's here, I've got a pair of 2's here, and I can make matches across my trees, so I have a pair of 2's here as well. Remember that this means that I can take out a 2 for each one of these pairs. So I can take a 2 out for this one, take a 2 out for this one, and take another 2 out for this one. Then what's left underneath my root? I've gotten the 4 done, I've gotten this 4 done. 3, yeah, 3 is the only thing left over. All these other things already split up as other stuff. All right, so 2 times 2 times 2 times the square root of 3. What do we have all together here? Two times 2 times 2 is 8 square roots of 3. There we go. Any questions? Okay. The other thing we said we could do was add and subtract these things. So let's say I've got, I don't know, square root of 18 plus 2 square roots of, let's see, 8. And the problem with adding, it's not the same for multiplying, is we have to have like terms. Any type of number that we're adding or subtracting has to be a like term. So for that here, that means that we have to have the same number and the same type of root to be able to add these. Well, they're the same type of root, they're both square roots, but they're not the same number. One is 18, one is 8. So we're going to have to break these up and see if we can simplify them down to something that is similar. So 18, we know is 2 and 8. I'm sorry, 2 and 9. 9 is 3 and 3. So what would this simplify down to? What's on the outside of my root now? What? 3. The 3 is the thing that matches up. And what's left on the inside? 2. Because it didn't match with anything. Okay? Then 8. It splits up as 2 and 4. 4 is 2 and 2. Now something to keep in mind here, though, is that we already had a 2 on the outside of this root, so it's going to drop down before anything else. Okay, I've got a pair of 2's here. That means I can take another 2 out. And there's a 2 left over, so it is left underneath this root. Now if we clean things up a little bit, 2 times 2 here, we get 4. So we have 3 square roots of 2 plus 4 square roots of 2. So if I have 3 square roots of 2 and I add another 4 square roots of 2, how many square roots of 2 do I have altogether? Seven. 3 plus 4 is 7. So I have 7 square roots of 2 altogether. Excellent. Give me a moment. Someone's having trouble getting into the stream. Okay. So again, this is what we covered last time. Okay, so we can multiply them, we can add them, and we can subtract them. What about dividing them? So let's take a look at division with these things. First of all, we can start really simply. Something like, yeah, that's perfect. The cube root of 8 divided by 64. Okay? So there's 2 ways we could tackle this. We could try to take the cube root of 8 and the cube root of 64 separately. One of the properties of radicals is that if we're dividing inside of them like this, we can separate it out so that it's cube root of 8 over cube root of 64. So that is possible. We can do that. However, remember that these roots act like parentheses. Whatever is underneath that root really needs to be taken care of first. So if we can simplify anything underneath this root, we really ought to do that. So instead what we're going to do is we're going to say, well, 8 over 64, that can be simplified, can't it? What can we simplify it down to? Just the 8 over 64 part, this fraction. What do both of these numbers have that they can be divided by? Yeah, they can both be divided by 8. So if we divide both of them by 8, 8 divided by 8, well, that's 1. 64 divided by 8 is 8. Good. So the simplified form of this fraction would be 1 over 8. Okay, and now would be the time that I would split this up. So go ahead and split it up. So we have cube root of 1 over the cube root of 8. Okay, what is the cube root of 1? 1. Yeah, it doesn't matter what kind of root we have. If 1 is underneath it, it's always 1. So we have 1 over, let's see, what's the cube root of 8? 2. Yeah, 2 times 2 times 2 is 8. And there we go. So again, remember that you can split these things up, but what you should do is make sure that you have it simplified as far as you can go before you split it up. Okay? Any questions? All right. Let's try another. So like this one. Square root of 12 over 48. So right now, if we look at these, if we were to try to split this up, we'd have square root of 12 and square root of 48. Well, do we know what the square root of 12 is? Nah. And we don't know what the square root of 48 is either. We could simplify them, but that's a lot of work. So again, what we want to do here is we want to simplify if we can. So 12 over 48, that fraction there, can it be reduced by anything? Do what? Okay, both of them can be reduced by 12. Whoops, not 12 over 12. 12 over 48. Okay? So if we take 12 out of both of these, what do we have left on top? 1. Good. And what about the bottom? Okay. So 1/4. So this is now the square root of 1/4. And I don't believe we can simplify that any further than it already is. So we can split it up now. Square root of 1 over the square root of 4. So what's the square root of 1? And square root of 4? There we go. Any questions? Does this make sense? Okay, good. Let's try some more. Where's that one I was looking at earlier? Okay, you might be faced with this as well. Square root of 126 divided by square root of 77. So they're not under the same root right now. We could put them under the same root and see if they have anything in common. So we could make this into the square root of 126 over 77. Okay. Do 126 and 77 have anything that they can both be divided by? It's little bit hard to see, yeah. They actually do. So both of these can be divided by 7. So we can make this into, let's see, 126 divided by 7 is 18, and 77 divided by 7 is 11. So we have 18 over 11. Can they be further simplified? No, they can't. So what this gives us is square root of 18 over square root of 11. Okay, well, can we take the square root of 18 and can we take the square root of 11? No. So here, we shouldn't just leave it like this. There's a few reasons why. First of all, we know that these could be simplified. Or at least one of them could be simplified. And there's another problem that I'll get to in a minute. But let's go ahead and simplify and see what we get. So first of all, 18, square root of 18. We know we can simplify that one. Because 18 is what numbers? 9 and 2. And 9, of course, is 3 and 3. Meaning we can take a 3 out and we'll have a 2 left over. So this is really 3 square roots of 2. And here comes that other problem. 11 does not simplify. It is already a prime number. That also means that it does not take a root very well. It gives an irrational number. And in math, we really don't like having irrational numbers in our numerator, our bottom of our fraction. The reason why is because you think about 1/2. 1/2 is telling us that we have a pie cut into 2 pieces. Okay? So 2 shows us how many pieces we have in this pie. Something like 1/4. Again, the bottom number is telling us what those pieces look like. 1, 2, 3, 4. If we have square root of 11, so square root of 11, that gives us 3.3166247. What do those pieces look like? How many pieces do we really have here? Well, it's really hard to tell. So we don't want this irrational number in our denominator because it doesn't make a whole lot of sense to mathematicians. So we've got to do something to this to change it. Okay, so I'm going to copy this down here to give us some more space. Okay. So how do we fix this? Well, the problem really isn't with the 11. 11's a perfectly fine number. It's rational. It's the fact that it's square root of 11. So what we'd like to do is get rid of the square root part and maybe just leave that 11 since 11's fine. Okay, so how do we cancel a square root? With a what? Yeah. Remember that the opposite of a square root is a square. And so if we multiply this thing by another square root of 11, then that's squaring, isn't it? Really what we have here with square root of 11 times square root of 11 is square root of 11 squared. Now remember, whatever we do to the bottom, we need to do to the top as well. So the top also gets square root of 11 multiplied to it. Okay? All right, so we've got a square root and a square. Those will cancel each other out, just leaving us with the number 11, which is what we wanted, and then we multiply all this together. So 3 square roots of 22, which square root of 22 can't be simplified. We know that because both of these are prime numbers back here, 2 and 11, prime numbers, and they don't have anything in common. So this would be the answer we're looking for. You want to make sure that all of your roots are as simplified as they can get. So like we did here, we simplified our numbers as far as we could, then we simplified our roots. But then the other thing is we need to make sure that we have a rational denominator. So we need to multiply that denominator by itself to make it rational. Any questions? None? Okay. Is that what I was looking at? Yeah, that's a good one. So let's just practice this real quick. 3 over the square root of 5. Nothing needs to be simplified here. 3 and 5 are already prime. But we need to rationalize the denominator. So what are we going to multiply the top and bottom by? Square root of 5, yeah. Okay? So if we multiply square root of 5 by square root of 5, what happens? Yeah, you're both right. So if we multiply both of these together, the roots cancel and we're just left with 5. And then what do we have on top now? 3 square roots of 5. Good. Let me throw you a curveball. Y plus 2 all over the square root of 3. So, what do we multiply the bottom and top by to get rid of that root? Square root of 3. Which means on the bottom now we have what? Okay. Still need to multiply the top by that as well. And it's the entire top that gets multiplied. So, if we multiply the entire top, in other words, we're distributing, what do we have over here? Good. Good. Y square root of 3 plus 2 square root of 3 over 3. Excellent. Any questions? Okay. One last thing before we go today. So remember, back to our properties of exponents. Let's say I have the cube root of x to the 6th. What do we do with that power and the type of root? What are we going to do to simplify this? What do we do with this power and this root? Do what? Divide. Excellent. So we divide the power by the type of root, and that gives us the simplified version. So 6 divided by 3 is 2, so this is x squared. If we had the square root of x to the 50th, 50 divided by 2 gives us x to the 25th. So what if we have the square root of x to the 7th? Well, before what I said is, yeah, we divide. 7 divided by 2, we get x to the 7 over 2. However, we can actually go further. What we're going to do instead is we're going to say, all right, just like these things that we can't take a root for, so like square root of 50, that comes out to be an irrational number, right? So it doesn't really take a root very well. So what we did was we factored it. And by factoring it, we found matches, and we were able to take some matches out and simplify this thing. The exact same thing works for this. So if we have square root of x to the 7th, we can actually factor this. We can factor this as something like square root of x to the 6th and x to the 1st. Now remember, the reason why this works is because these are supposed to be multiplying to get this original number, right? So x to the 6th times x to the 1st, what do we do when we multiply these things that have powers on them? What do we do with those powers? Add them. So 6 plus 1 gets us 7. So yeah, we can tell that x to the 6th and x to the 1st are factors of x to the 7th. Okay. So the way that we look at this now is we keep on breaking off powers from this x thing, so we can keep on breaking x to the firsts until we find a number that will divide by 2. So will 6 divide by 2? Yeah. What do we get from that? X to the 3rd. That's like making our match. That's the thing that gets to come out. And then this thing left over, x to the 1st, that didn't have a number that could divide by 2, is still under that root. So square root of x to the 7th, if we simplify it, is x to the 3rd square roots of x squared. X to the 1st. Let's try another. But any questions before we move on to the next? All right. So let's try the, 4th root of x to the 18th. Okay. Two ways of doing this. We could make this into, a factor problem, which we're going to need to do eventually to simplify it. Remember what I said about what we can do with these numbers here. When we try to take a root of a power, what do we do with these two numbers? We divide, right? So that gives us something like x to the 18 over 4. Can that fraction be reduced? Yeah, let's go ahead and reduce that fraction then. 18 over 4 is what? 9 over 2, yeah. So we've got much smaller numbers now. Let's use that instead. So put this back in radical form. This is what kind of root? A second root or a ninth root? Second root, good. Square root of x to the what? 9. So instead of dealing with these larger numbers over here, we have much smaller numbers to deal with. So if you recognize that these numbers can be, reduced, you go ahead and do that. Okay, so now 9 won't divide by 2. Let's see if we can make it divide by 2. So let's split off an x to the first. What's left over? X to the 8th. Will 8 divide by 2? Yeah. So we get 8 divided by 2, x to the what? 4th. And what's underneath the root? X to the first. Does this make sense? What questions do we have? None? Okay. Try another. Two variables. Doesn't matter that we have two variables though. It still works the same way. Okay. So let's look at x to the 6th first. Can we divide 6 by 3? Yeah, absolutely. If we go ahead and do that, we get x to the what? Good. Okay, now moving on to that y, we have y to the 14th. Does 14 divide by 13? No, it doesn't. So we're going to need to split stuff off of here. So if I split off and a y to the first, how many do I have left over now? Yeah, y to the 13th. Well, 13 and 3 still don't divide, do they? All right, well, let's split off another one. Does 12 divide by 3? Yeah. So we get y to the what? 4th. Okay, so that's taken care of. Well, we got that. But we've got these y's hanging out here under the square root. And how many do we have? So it's y to the 2nd. Excellent. And of course we can put numbers into this mix as well. Let's do the, 4th root of 32 x to the 5th, y to the 7th. Okay. So, let's tackle this. First, this number, 32. Does it take a 4th root? We need something that times itself 4 times is 32. Yeah, can't really think of anything. Let's break it up and see if we can find something that way. So what is 32? 8 and 4. 8 is what? 4 and 2. 4 is, of course, 2 and 2. So again, we need a group of 4 that match. Do we have at least 4 things that match? Yeah. We have all these 2's right here. So they match. So that means we can take a 2 out. And what will be left over under here? 2. Well, not quite at the x yet, but good. Okay? Next, x to the 5th. Well, obviously 5 doesn't divide by 4. So we need to break this up. X to the 4th and x to the 1st. Well, 4 divided by 4 is what? So we get x to the 1st come out here. And what's left in here? Good. Now we just have to worry about this y. So 7 doesn't divide by 4. So we split this up. Y to the 6th and y to the 1st. Still doesn't divide very easily. 6 and 4. So we're going to have to split this up again. Y to the 5th and y to the 1st. Still doesn't divide because 5 doesn't divide by 4. So y to the 4th and y to the 1st. And there we go. So this will give us y to the what on the outside? Y to the 1st. And then how many y's do we have left over underneath? 3. Perfect. What questions do we have? None? Making sense? Feeling good about it? Think we could do it? All right, excellent. Then I believe that will do it for today. So remember, that review, I want to see it before midnight on Wednesday. Other than that, I hope you have a good day, and I will see you on Wednesday.